Hello, welcome to this Marmon electrical presentation today. We are going to talk about fire-resistant wiring systems and consider the differences in performance between a cable passing a fire test and a full wiring system being fit for the purpose intended. My name is Richard Hosier. I have worked in the electrical cable industry for 30 years in executive, technical and business development roles and with some of the biggest global cable manufacturers. Today, I work with the Marmon Electrical Group in America in development of special cables used for demanding applications in international markets. Marmon Electrical is a unique group of 18 major cable manufacturers with over 2,000 employees whose synergy offers tremendous breadth of product offering, advanced research and development, continuous innovation, and with the financial strength of Marmon Holdings Incorporated under our parent, the Berkshire Hathaway Company. Marmon Electrical manufactures electrical and electronic wire and cable for energy-related markets and other industries. Applications include industrial power and instrumentation, aerial and underground utility distribution, and environments where exposure to harsh elements is anticipated. Markets also include space, aerospace, defense, telecommunications, computers, transit, and appliances. Our talk today will focus on those special cables which supply power to critical life safety and firefighting equipment in buildings. These cables are required to keep working as part of a wiring system in order to keep this essential equipment working during fire so people can evacuate safely, property can be saved, and as a support for first responders. Now, based on factual technical comparisons, the Marmon Electrical Group of companies in America manufacture some of the best performing fire-resistant cables in the world. Because of this, we want to take our technology to the world to help other countries and their people improve fire safety in buildings. Building codes and regulations for fire-resistant cables are not the same in all countries around the world. In many developed countries, building codes require life safety and firefighting equipment to be installed in tall and large public buildings, metro subways, hospitals, road tunnels, and other critical public infrastructure. This essential and life-saving equipment requires special electrical cable systems to ensure that the emergency equipment will continue to work reliably, even if the cables supplying them power are exposed to the fire. Such equipment commonly includes firemen's lifts, smoke and heat extraction systems, fire alarms, evacuation systems, sprinkler and hydrant pumps, and emergency power generators. Because America and Canada have very stringent requirements for fire safety in buildings, they also have a high prescribed performance standard for testing essential wiring systems, and their building codes are prescriptive. The key word here is wiring systems and not just cable, as it is the whole wiring system that needs to be tested and approved together, and not just as individual parts. Outside America and Canada, most countries have building codes which adopt a cable-only test standard protocols, which are based on a minimum required performance for the cable only. The problem for countries adopting these minimal cable-only performance test standards is that most often this minimum cable performance is used in every building, regardless of what performance might actually be needed. This means the same minimum performance cables are used in large public buildings like hospitals, tall skyscrapers, metro and road tunnels, which have long evacuation times, as is used in small commercial buildings with short evacuation times. This is because there is only a test requirement for the cable itself and not for the full wiring system. Developers and contractors will always buy and install the cheapest product which meets the minimum code. But regrettably, minimum product performance is not always the required system performance. There is a growing awareness in some countries that minimum standards with a product-only approach to certification is not always providing the level of safety needed or expected by designers, owners, and occupiers of buildings. Investigation into recent major disasters, including the Grenfell Tower fire in London, has brought building code standards and the responsibility matrix between owners, designers, inspectors, contractors, and regulatory authorities into sharp focus. A fragmented, product-only approach to compliance testing, rather than a more holistic testing of full system performance, can lead to premature failure, with subsequent responsibility falling between the cracks, leaving any liability difficult to define. The final report into the terrible Grenfell fire, made to the British government, clearly identifies that buildings are a system, and a systems approach is needed to meet building safety objectives. When it comes to life safety and firefighting equipment, the essential wiring system comprises of not just the cable, but all of its associated fixing, supports, conduits, brackets, and clamps. A cable cannot be tested in isolation and then qualified as a system because of known negative and interference reactions between the cable and its installation components at high fire temperatures. As shown in the picture, fire can quickly burn away any non-metallic cable jacket, leaving cable fixings no way to support a cable's weight in vertical and inclined installations, which can lead to failure. It has also been identified that high fire temperatures, zinc in galvanized conduits can react with the copper conductors of cables to cause premature failure of the circuit and, of course, the equipment the cables serve. Conductive gases released from burning insulations can also cause circuit failure in conduits under fire conditions. It is therefore essential that fire-rated cables must be tested in a realistic scale, in a realistic fire, together with all of its fittings, supports, fixings, and fixing distances as part of a system, and not just testing the cable alone, as is the current case with some common British and IEC fire-resistant cable test standards. To visualize the significant differences in common fire-resistant cable test methods around the world, this table identifies the strengths and the weaknesses of each test standard. It becomes clear from a review that only the American UL 2196 test protocol provides any meaningful and representative evidence of the actual installed performance of a full fire-resistant wiring system installed in a building. Now, some people might ask if such stringent testing is required, but what we must understand at all times is that these wiring systems provide electrical power to keep life safety and firefighting equipment working during emergency to facilitate evacuation. This saves lives and protects property, as well as supporting the efforts of the first responders. This graph shows the standard time temperature curve to ISO 834 Part 1 and ANSI UL 263. This time temperature protocol is used to test and certify every component, system, and structure in a building needing a fire resistance level, or FRL. Germany, Belgium, Australia, New Zealand, America, and Canada also use this fire time temperature curve to test fire-resistant cables for use in fire-resistant wiring systems. Britain, most parts of Europe, Asia, Middle East, and many other countries around the world use British standards or IEC standards for testing fire-resistant cables. These British and IEC tests use a small flame source on short cable specimens rather than a furnace test of cables installed in a similar way to the way they will be used in buildings. These flame-only British and IEC tests are also conducted at significantly lower temperatures and in very different support and fixing configurations than the cables will likely be actually installed with. Because the fire-resistant cables and wiring systems are likely to be exposed, in the same fire as every other building element, it does not make sense to allow concessions for the very cable which enable the life safety and firefighting equipment. Cable manufacturers are mostly corporate entities who produce cables for profit. They will make cables as cheap as possible that meet a minimum standard, because in our world, it is always the cheapest product that wins the order. In the United States and Canada, where minimum required performance is for a full wiring system, then manufacturers in these countries make and sell cables and wiring systems which meet these system requirements. In countries where there is a lower cable-only test requirement, then cable manufacturers in those countries make cables to only meet those minimum cable test requirements. In today's modern world, the built environment is very different to even 50 years ago. Buildings are taller, they're bigger, there are more mixed-use transportation, retail, commercial, and residential developments. Evacuation times in these larger buildings can be longer, especially in large hospitals, subways, skyscrapers, and large public infrastructure. Constructions today increasingly use new, light, man-made synthetic building materials, with many of these having higher calorific values. This, with increasing polymeric and plastic contents in buildings, can increase the fire load and result in a higher heat release rate and faster temperature rise time. It is not appropriate to use a single cable-only minimum standard for every essential wiring system in every building. And there is certainly a very strong case for not using these cable-only test standards for many large healthcare buildings and very high-rise or subways and other critical public infrastructure with long egress times. The fundamental questions that designers, authorities, and building owners must ask themselves is, do I just want the cable part of my essential wiring system to meet the minimum code, the minimum performance, and the minimum price? Or do I want the whole wiring system to both meet code and be fit for the purpose required? VITALink MC wiring systems provide you a fully tested, fully certified, and fit-for-purpose essential wiring system for the most demanding buildings and critical public infrastructure. For further information, please download our white paper on fit-for-purpose essential wiring systems on the URL link shown on this page. Alternatively, contact us at the address shown below.